Look at this photograph. A pale blue dot suspended in a scattered beam of sunlight, smaller than a single pixel. That is Earth. Everyone you have ever loved. Every human who has ever lived. Every war. Every symphony. Every civilization. Every prayer. Every empire. Every heartbreak. Every dream. All of it on a mote of dust caught in a sunbeam. That photograph was taken in 1990 from roughly 6 billion kilometers away, and here is the terrifying truth. 6 billion kilometers is nothing. It is not even the first step of our journey. Today, we are going to travel from that pale blue dot to the edge of everything we can see, and what we discover along the way will forever change how you see yourself. Our journey begins close to home, the moon. 384,000 kilometers away. It feels distant. If you drove a car down the highway, it would take you more than 160 days to get there, but light crosses that distance in just over 1 second. The moon is our doorstep. We have barely left the house. The sun lies roughly 150 million kilometers from Earth. Light makes the trip in 8 minutes and 20 seconds. On a passenger jet, flying nonstop, you would reach the sun in about 19 years. And yet the sun is still our backyard. We have not even left the property. Mars, at its closest approach, is about 54 million kilometers away. But when Earth and Mars orbit to opposite sides of the sun, that distance can grow to more than 400 million kilometers. A passenger jet flight would take decades. The vastness between worlds is not just distance, it is time. This is why we sent machines into space before humans. But Mars is still inside the small bubble we call home. To understand real distance, we have to go further. Neptune, the outermost planet, orbits about 4.5 billion kilometers from the sun. Sunlight takes over 4 hours to reach it. At Neptune, the sun is no longer a blazing disk in the sky. It is a distant, brilliant star. Launched in 1977, Voyager 1 has now traveled more than 25 billion kilometers from Earth, farther than any human-made object. It has been flying for nearly 5 decades. It has crossed into interstellar space. And yet, if we count the distant Oort Cloud as the sun's outer frontier, Voyager has not truly left the sun's domain. The Oort Cloud is a vast shell of icy bodies that may stretch as far as 100,000 astronomical units from the sun, almost 2 light years. This is where the sun's gravitational grip fades into the pull of the galaxy, and we have never been there. At its current speed, Voyager 1 will not even reach the inner edge of the Oort Cloud for about 300 years. It may take around 30,000 years to pass beyond it, but the Oort Cloud is only the shore. Now we cross the ocean. Alpha Centauri is the nearest star system to our own, about 4.4 light years away, 41 trillion kilometers. If Voyager 1 were aimed directly at it, which it is not, the journey would take tens of thousands of years, longer than human civilization has existed. The closest star system to our sun is so impossibly far that even our fastest ancient messenger would need a span of time longer than recorded history to arrive. And Alpha Centauri is only the beginning. Our galaxy, the Milky Way, stretches roughly 100,000 light years across. It contains hundreds of billions of stars. Every star may host its own worlds, and within this galaxy there is a tiny expanding bubble, the faint reach of humanity's earliest radio leakage. Those signals have traveled a little over 100 light years from Earth. That sounds enormous. It is nothing. Compared with the Milky Way, our radio presence is a microscopic whisper. Outside that tiny sphere, across nearly the entire galaxy, humanity has never been heard. We are silent. We are invisible. The galaxy does not know we are here. But the Milky Way is not alone. Our galaxy belongs to a small family called the Local Group. More than 50 galaxies scattered across millions of light years. Andromeda, our nearest large galactic neighbor, is about 2.5 million light years away. The light reaching your eyes tonight from Andromeda left that galaxy while early humans on Earth were learning to shape stone tools. That light crossed intergalactic darkness for 2.5 million years just to arrive here now, and yet the local group is only a village. We move on. The Virgo Supercluster contains many galaxy groups and clusters stretched across more than 100 million light-years. Our local group is only a fragment inside it. Thousands of galaxies, each with billions of stars, each with its own history, its own collisions, its own black holes, its own dead worlds and newborn suns. But Virgo is only part of something much larger. We belong to a structure called Laniakea, a vast supercluster scale flow about 500 million light-years across. It contains roughly 100,000 galaxies moving through an immense gravitational web. At the heart of this motion lies the Great Attractor, a massive region partly hidden behind the dust and stars of our own galaxy. The Milky Way, the local group, and countless neighboring galaxies are all moving through space as part of this flow. Every star in the Milky Way, every planet, every comet, every speck of dust. All of it is moving through the gravitational river of Laniakea, and even that is not the end. The Great Attractor itself appears to be influenced by an even larger concentration of mass beyond it. The Shapley Supercluster. Gravity on a scale that does not feel like force anymore. It feels like fate. Imagine it this way. If the entire universe were an ocean, Laniakea is one wave, and there are countless others. Now we arrive at the boundary of everything we can observe. The observable universe spans roughly 93 billion light-years across. How can it be 93 billion light-years wide if the universe is only 13.8 billion years old? Because space itself has been expanding since the Big Bang. Distant galaxies are not simply racing through space faster than light. The space between us and them is stretching. And in the most distant reaches, some galaxies are now receding from us so quickly that the light they emit today will never reach us. They are not just far away. They are lost to us forever. The true size of the entire universe beyond what we can observe may be vastly larger. It may even be infinite. We may never know. What lies in the spaces between superclusters? Voids, enormous cosmic deserts where galaxies are rare and darkness dominates. The Bota's void is hundreds of millions of light-years across and contains only a small number of known galaxies compared with what a region that size might otherwise hold. Imagine an ocean with only a handful of islands. This is the real texture of the cosmos. Not an even sea of stars, but a foam of filaments and voids, unimaginable density beside unimaginable emptiness, light beside silence, structure beside absence. Now return to that photograph. That pale blue dot, the only home we have ever known, a world of 8 billion people, of oceans and mountains, of love and loss, of cities, languages, forests, songs, graves, children, and dreams, everything that has ever meant anything to anyone, suspended in a void so vast that our entire galaxy is less than a grain of sand on a cosmic beach. The observable universe may contain hundreds of billions, perhaps even trillions of galaxies. And we live inside just one of them, on one planet, around one star, among hundreds of billions. We are not the center of the universe. We are a momentary pulse on the edge of a single spiral arm in a galaxy that is itself moving through a gravitational current we barely understand. This is not despair. This is perspective. Every argument, every worry, every ambition, every fear that feels too large to survive. Hold it up against 93 billion light-years and ask yourself what it really is. The universe is not big. Big is too small a word. The scale does not get larger, it becomes impossible. And yet here we are, looking up, asking questions, building telescopes, sending probes into the darkness, a species that can hold the entire cosmos in its mind while standing on a mote of dust. That is what makes us extraordinary. Not our size, not our power, not our importance, but our ability to understand how small we are and keep looking anyway.